The function rules graphed in problems 1 through 3 represent linear functions. You can also graph a nonlinear function rule. When a function rule does not represent a real-world situation, graph it as a continuous function. Problem 4. Graphing nonlinear function rules. What is the graph of each function rule? A, y equals the absolute value of x minus 4. So, step 1, we'll make a table of values. We'll select some inputs. A rule of thumb when selecting input values for your table of values is always select at least 2 negatives, 2 positives, and 0, so that you can identify any behavior in the graph both to the left of 0 on the x-axis and to the right. Substituting those inputs into the function, we find our outputs and create a list of ordered pairs from which to graph. Step 2, graph the ordered pairs, connect the points, and we get this V-shaped absolute value graph. B, y equals x squared plus 1. Make a table of values. We'll choose 2 negatives, 2 positives, and 0 for our x values. Y equals x squared plus 1, substituting in each of our input values. We find our output values and make a list of ordered pairs. We graph the ordered pairs and connect the points. In this case, we have to connect the points, not forming a V, but more of a U shape. If you attempted to connect these points, you'd find they're not linear, either on the left-hand side of the y-axis or on the right-hand side. So we get this U-shaped graph, shown here. Your turn. What is the graph of the function rule y equals x cubed plus 1?